Welcome to the world of Arduino. We're going to start out with a simple exercise simply to familiarize yourself with the Arduino software and also the microprocessor. In this, we are going to download the software and then plug our microprocessor in. Make sure it's working. Make sure that we know what port it's going to show up on in our computer. And then we're going to upload a sketch to the microprocessor. And then to kind of play around with the code a little bit, we're going to do something simple and we're going to change the blink rate of the built-in LED on the microprocessor. So those are our steps. Those are our goals for this lesson. Let's go through and see if we can't figure out how to do all these things. So first off, if you just go to the Arduino downloading page, you're going to download the software. You do want to make sure you choose the IDE that's best for your specific computer. And so download that and then you'll be ready to go. And what that is this is the software that's going to run your code. Now, it may seem daunting at first to be like, I'm going to have to do code. Well, what you need in order to run these microprocessors is the ability to read code. You don't necessarily have to write code because you will be really good at Googling. And there are so many communities out there whose job it is to help you write code. And so it's really easy to borrow and copy and paste little snippets of code into the code as long as you understand the basic setups of the code. And so we're going to look a little bit today about how to read code. But first off, download that IDE and then come back to this video. The next thing I want you to figure out is what type of Arduino do you have? So we might have an Uno, which I have two examples shown here. This one's an Arduino, this one's an Elegoo. Elegoo is just the name brand. They're both going to have the same type and the same pins as each other. So they're both Unos, and then this here is a Nano, and so this one's the cheaper one. This one you will actually plug into a breadboard, and we'll show you how to do that in future videos. But the first thing I want you to do is figure out which type you have and then Google it. And you might say, why? Well, I want you to Google your type plus a schematic. And if you do that, you might get something like you see here. This is probably my favorite lesson on how to identify all the parts of an Uno. And so they compare it to a cow. It's nice to know what the pieces are. That's the same thing with an Arduino. You need to know what's going on. So we've got some analog components. You've got ground. I think that's shown in a below one. But you've got ground. You've got your power supply. You've got a fuse, and so that's typically one of the things that might mess up. You have some pins and some lights that are going to show up, and then you have some digital inputs as well. And so all of these things are important, so it's just kind of good to Google it, figure out what the wiring schematic or the wiring diagram is for your specific Arduino. And you'll hear me call them Arduinos. Even if they're not all Arduinos, I'll use that name anyway. Sometimes I'll call it a microprocessor. Here's one for the Nano, and so you'll notice it's very similar. The main difference is you don't have this power supply or this power jack right here. And so that power jack would allow you to program the Arduino and then move it somewhere away from your computer, collect data, and then move it back. And so the Nano doesn't have that functionality. But it's got a mini USB jack here for power, and then it still has the ground, the digital pins, and the analog pins. And so just kind of knowing these things is important. It also has some lights that'll show up if it is indeed working. And so look at your schematic and see if you can't figure out what all the pieces of your Nano or Uno are. Next, I want us to plug in our microprocessor into the computer. When you do that, so if we plug like this Nano in, you should be able to hear a noise that you typically hear whenever it is working on your computer. And so device drivers, that kind of thing should begin working, and you should get some kind of light. The very first time I plugged mine in, I was given a faulty USB. So I have labeled it a bad, not working, don't use me. And if I plug this one in, you'll notice I'll get nothing when I plug mine in. And so at first I was wondering if, does the Nano not have lights on it? That kind of thing. But in actuality, it does. It's just it was a bad USB. And so notice I plugged it in and nothing happened. And so that's the first step, is plugging in your microprocessor and just make sure you see something. Lights, something, you hear a noise that tells you that yes, stuff is indeed working, that kind of thing. It's the same thing. If I plug in my Uno, you're going to get noises as well. So see how you heard noises and then immediately you start to see lights on the board. Same thing for this one as well. So all you're doing is trying to plug stuff in, make sure you see lights. If you do that, you're doing good. The next step is going to be identifying the COM port. Next, I want you to open up your program, and it could look like this. There's lots of different things. You could always go File, New Sketch if you wanted to. But what I want you to do first is go under Tools, under Board, choose the Arduino type that you have. So an Uno, a Nano, maybe you bought a Mega because you're really excited about this. Whatever you wanted to buy, choose it. So I have a Nano plugged in right now. And then also the most important part is you have to choose your port, your COM port. Now I have 3 listed here and none of them are labeled. If I would have had my Arduino Uno plugged in the name brand one, it looks different. So now I have plugged in my Arduino Uno, I would have changed it to Arduino Uno port, and then see how now it tells me what my port is? That's because it's a name brand Uno, and so it automatically identifies it for me. So I would have selected it. Now what happens whenever I put in my Elegoo one? See how it also identified it, but this time it thought it was COM4, okay? But if I go back to my Nano, it is not going to automatically identify it, and I need to figure out what COM port it is actually running under. So I'm going to change it under Tools to an Arduino Nano, and then I'm going to go into my device manager. And this is going to be a slightly different process depending on what operating system you're running. If you're running a PC or a Mac, that kind of thing. Me, I don't have administrative privileges on my computer, so I just hit OK. I don't need to change anything, I just need to look. And so with my COM ports, notice now how I have 3 COM ports. 1 and 2 are both some serial over Bluetooth. Something's going on there with Bluetooth. And then the next is my USB. But what's important is I may not know for sure, yes, this Nano is in fact COM7. But watch what happens when I unplug my Nano. It refreshes, and if I scroll down, it is gone. If I plug it back in now, it's going to reappear. That's how you confirm that yes, indeed, my Nano is coming in through COM7. That's all the information I need. I can close that. I can go into Tools, make sure it says Arduino Nano, make sure my port is COM7. If I have done that, then these next steps will work appropriately. What I want you to do next is go under File, Examples, and then these are basic examples that come built into your kit that let you test things. So go under O1, Basics, and then Blink. I can close my other program. I no longer need that new one, and I can open this one and make it bigger. So this is my code. This is the code that is going to be ran in a second. There are different components to it. For instance, you see where this little slash is? That single slash is going to designate a comment. That comment is things that are not going to be included in the code. So basically, anytime you see this slash, it's going to say, hey, computer program, ignore everything that's written after this slash until you see another slash. And why it might do it is this is where you put information. What's this program meaning to do? Who wrote it? What's the purpose? What Arduinos were used? Anything like that. Okay, and so those are just called comments. And then after comments, now we are going to have either single line comments, which are designated by 2 slashes, or our code. And so anytime you have a question like, what does void, what does setup mean? Arduino has this references website, which lists all of these functions. Think about functions like mathematical functions. They do something, okay? So for instance, if I wanted to ask the question, what does void or setup mean? I can come down here and I can do Control Find Setup. And then notice it has setup here. And this is written in a C++ coding language. So if I click on setup, it's going to give me a description of what's happening and an example code. Okay. So setup is just telling me that I'm starting to initialize certain pins, certain libraries, certain something. And so with pins, remember that was where we looked at the layout of my board, and I might have a digital pin or an analog pin. And then with void, it's saying nothing is returned when this statement is completed. So this is sort of like setting up a mathematical function. You are telling the computer what to do and when. Okay, and you'll get better at kind of identifying these in a little bit, but the main thing is we've got comments and language, and notice we've got brackets. Anytime you have a bracket, it's just like using Excel. You need a starting bracket, end bracket, okay? And these right here are my procedure name or my function. And then what's inside of that is going to be my input values. Okay. And so we've got what's returned, what the function name is, and then input values. All right. That may not make a lot of sense to you now, but we'll work on it a lot so it'll kind of function. Okay. All right. So let's come down here and look at the rest of this code. So void, so nothing's going to happen, okay, but loop just means we're going to do this continuously until I tell you to do otherwise. So in this case, what am I going to tell my nano to do? Well, I'm going to tell it to turn the light on. Notice this little comment here, so it's a one-line comment. So it's going to turn the LED on. The word high simply just means on, and low simply means off. And how it does that is it puts a high voltage on the internal built-in LED that's indicated right next to that red light. Okay, and then this 1000 is a delay. So this code is saying turn the LED on and then wait a second. Okay, and this is a second. Even if there's 1000, this is how many thousandths of a second. So if there's 1000 thousandths, that's a second. Okay, and then it says after waiting 1000, then turn the light bulb to low, which is really turn the voltage low because we're controlling the voltage here. Okay, and we can control it through this micro USB port, and then it's saying wait a second. So what's going to happen is we are going to compile it, or we're going to verify and compile it. So I hit my little verify button. You'll see at the bottom that it's compiling. All that's doing is it's searching through and looking for errors. So when your computer program is compiling or verifying, it's basically looking for egregious errors, so things that are wrong. So for instance, maybe you don't have a semicolon after a statement, or you have an initial bracket but not a final bracket. It's looking for things like this. Is it going to know that you meant low when you've written high? No, it's not going to know errors like that. It's just going to know codes and errors like a grammatical error or a spelling error, sort of like spell check does. But is it going to know whether or not the statement that you made is true or false? No, but it's going to be able to tell you whether or not your spelling is correct, if you will. Okay, so that's compiling. After you compile, then you hit this button here and it's going to upload. And watch what your nano or your microprocessor does while that's happening. Do you see all those buttons light up? That tells you something is happening. So while it's uploading, it's slowly doing that, and it's kind of registering and uploading it to the device. So now my sketch has been uploaded to my microprocessor. All right, now notice my code is blinking. So what happened? Well, first off, we did this void setup. So it is set up. It is setting up, hey, I need to initialize my pin mode. And so my pin mode here, this right here, is basically saying I need to do something. I need to establish that I'm doing something to my built-in LED. Okay, that's this thing that's blinking right here. It does this one time. Okay, then the loop is doing something over and over again. So right now, it's on a second, off a second, on a second, off a second. We could change either of those. So watch what happens if I change this to 5000, which is 1 second. Let me upload it and see what happens. So it blinks a whole lot. That tells you it's uploading. Okay, now it's on, then delay 5 seconds, off, on. Wait 5 seconds, off, on. And notice, my off on was very quick, whereas it's turning it on, wait 5 seconds, turn it off, wait 1 second, turn it on, wait 5 seconds, turn it off, wait 1. And so you can control this. Change it maybe to 500 or maybe 100. Let's change both of them to 100. Watch what happens when I change that blink rate. So now that's basically going to be 1/10 of a second delay. So everything's registering, it's downloading. Now look how fast it's blinking. It's blinking like that because it is 1/10 of a second is my delay, both on the on and the off. And so just by playing with these types of things, you're able to control the rate of blinking for a built-in LED. Why is this important? This is just establishing that we can read one part of a code, make changes in the sketch, and then watch what happens on our microprocessor. If you did all of these things, then you understand the very bare minimum in order to run a little bit of code on your microprocessor. So congratulations on finishing your first lesson.